problem, kids? What were the p-values? Or what did we say the p-value was originally? Wasn't it 4? 4? Okay. And then what did we say the q-value was here? Ooh, careful. It was 6, right? So what were all my factors of p then yesterday, guys? What are the factors of 4? 1, 2, and 4, right? Okay, and what were the factors of 6 here yesterday?
1, 2, 3, 6.
So 1, 2, oops, I'm going to back up here. Oh, let's see. Three and 6, you said? All right. Then we had to look at this idea of p divided by q, and we said, well, we got to take all the p-values and divide by q. So I went 1 divided by 1. I didn't write that because that was 1. Then we had 1/2, I think, was the first one. Is that right, guys? Okay, and then I would have had 1/3. And 1/6. Okay. Let's see, we had 2/3. 2/6 was 1/3. 4 over 1. Count 4. 4 over 2. We had 4/3. Was 4/3 the last one there, kids?
Yeah.
All right. So here's what we're going to do, guys. What root did we find yesterday that absolutely worked for us? Which one gave us a remainder of 0 yesterday? Okay, so 1/2 gave us a remainder of 0. So we said, well, if I go rational root theorem, let me do something here quickly. I don't want to do that. We had this rational root theorem, 1/2 was a value. Is that correct? What were the coefficients on that function again, kids? What was the coefficient on that function for synthetic division?
I don't know.
Anybody?
I have no idea.
We're on example 4.
Okay, 6,
Okay.
negative 11, negative 16, positive 2, and positive 4.
Okay. So we went through this yesterday and we said, you know what? We know 6 is going to work. 6 comes down here. Half of 6 was what, kids? 3. And then this was negative 8. And then this was negative 4. This was negative 20. What's half of negative 20? Negative 10 made this negative 8. Half of negative 8 was negative 4. Ooh, we got this remainder of what, kids? 0. So we knew one of the roots had to be what yesterday? What value worked up here yesterday?
1/2.
1/2. Okay, now, I'm going to tell you this right now. Yesterday in 6th hour, we went through all the whole number values up here, and guess what happened yesterday? None of those worked. Not a single one worked. So here's what I'm going to have you guys do. I'm going to assign you one to do. Okay, we know 1/2 works already, right? So on your own, maybe, is there a blank side on the back of your notes at all, guys? Why don't you guys all go to a blank side? Write down these coefficients for me. We'll write down 6. Write down negative 11. Write down negative 16. 2 and 4. And we already know that 1/2 is going to work, right? Okay. So I'm going to assign you a value to check. Gabriel, I want you to do negative 1/2 for me. Okay, Annika, you're going to do the 1/3. Check and see if 1/3 is a root. Xavier, you've got negative 1/3 for me, okay? Jaden, can you do 1/6 for me?
Yes.
And Lex, I'm going to have you do negative 1/6 in there for me. Maddie, I'm going to give you positive 2/3. Shane, you got negative 2/3. Jordan, take positive 4/3. And Kate, you've got negative 4/3, okay? You guys just make sure everybody's doing everything right. You got it? Let me know if anybody gets 0 as a remainder. I want to show you what's going on here. Sterling, did I give you one? Oh, you're lucky. You check and make sure everybody's doing everything right, okay?
Can you put up the 1/2 so we have like a, because
Yeah, hang on a second. Like the synthetic division that I did?
yeah, right,
Yeah, oh yeah.
Carson, I'm having a brain fart and I don't understand how to do it with the fraction. I think
Bring this down, right?
yeah, bring that
6
down.
times half is 3. Add.
Okay.
Okay.
Yeah, that's what I thought. But, oh my god. Okay.
Has anybody gotten another 0?
Carson, she has a like upgraded calculator, so can you come over here? It's like, yeah. How would you put 2 and 2 6 on this? Because when you hit that, it does that, and if you go to the second, it does that.
Well,
No, sir.
you're not going to get 0.
I'm definitely
What if it does this?
There's no way.
Okay, that's what I would put. Okay.
Students going on an academic decathlon field trip to UNI, please go to the front of the building at this time. Students in academic decathlon going on the field trip, please report to the front of the building at this time.
Who had negative 2/3? Got what? Well, you did?
Yeah.
All right, so hey, everybody stop where that. Cheyenne, you got 0, buddy?
Yeah.
As a remainder? Okay. I just want to do this up here real quickly. So Cheyenne, you had negative 2/3, right?
Yeah, 4 and 2 6.
Okay, I'm going to show you a shortcut today on how to finish this. Anybody else get 0? Is that a no? Cheyenne, run your numbers for me, kid.
6, -15. Oh no,
Negative 4?
Yeah.
Okay.
-15.
Okay.
10, -6, 4, 6, -4.
Perfect. Okay, now I want to show you something. What do we have for 2 solutions already, kids? Well, we've got 1/2 and negative 2/3. Now this is where I want you to make sure you pay attention to this. All right, I want you to make darn sure you pay attention. Once we started this function, we started out by saying we had a function that was degree. What was the degree of this function when we started, kids? What's the degree of this function we're working with? 4. Okay, it means we're going to have how many solutions in it? 4. We've gotten how many of them? 2. Okay. I want to show you something right here, and this is going to be really important. All right. We found 1/2 right off the bat. Okay. Found 1/2 right off the bat. And I'm going to go back to this. I want you to write down what I'm about to write down off of this. So I'm going to get rid of Cheyenne's work here. And here's what I want you to make sure you have. Did you guys get the 1/2 written down yesterday? You got all this for 1/2 written down? Okay, here's the deal. This is what I want to build off of right here. Okay, I know that negative 2/3 is another solution. Do you guys agree with that? So what I'm going to do is I'm going to come back down to the one where we took a factor of 1/2 out. And now I'm going to come down to our result here and say, okay, I'm going to put that negative 2/3 in here with our result. And I'll show you why we're doing this. All right? This is going to be different from what Cheyenne got. We started these out as the whole function, and we looked for some 0 remainders. And we got a 0 remainder with 1/2, and we also got it with negative 2/3. But I'm going to take this negative 2/3 and put it into the quotient when we factored out 1/2. So watch what happens here. I'm going to bring this 6 down now from the work that we did up here when our factor was 1/2. Help me with the math, kids. What's 6 times negative 2/3? What's 6 times negative 2 divided by 3, in other words? Wouldn't 6 times negative 2/3 be negative 4, kids? I mean, think about it. 6 times negative 2 is negative 12. Negative 12 divided by 3 is what? Negative 4, okay? Add these up. What do you have? Negative 12, okay? Okay, go 12 times 2 divided by 3. I know a negative times a negative would be a positive. 12 times 2 divided by 3. Where are you at? 8? Is that right? Oh, this should be a negative 20 right up here. My mistake. Hang on. Okay, so this should be an 8 right here. When I add this up, this is negative what, kids? 12. And this should be a negative 8 up here also. Does that do that? Okay, so this will be negative 12 again, you said? Negative 12 times negative 2/3, we just found out was 8. What do I get for a remainder here, kids? Okay, here's the deal. We started out with a 4th degree function, took out a factor of 1/2. This is what it gave us for these values. Okay, now I took out the negative 2/3 that we knew was a factor. We're down to this right here. All right. Here's what you can do. What you're trying to do is get down to a quadratic, because what this means now is that after you've taken the factor of 1/2 and negative 2/3 out, you have a constant of negative 12, an x to the first of negative 12, and an x to the second of 6. Okay? What we're trying to say is this. I found 2 factors, 1/2 and negative 2/3. And once I've taken those out synthetically twice, we're down now to a factored function of 6x squared minus 12x minus 12, and we want that to equal 0. Okay? You guys remember quadratic formula? Remember the quadratic formula?
X equals negative b plus or minus the square root of b squared minus 4ac.
And you're singing that?
Yeah. This
Oh.
Bill taught me.
Oh, did she?
Yeah.
Cool. Sing that, huh? Yeah, you're exactly right. I could use quadratic formula here now to do that. You guys okay with that? If you get this down to a 2nd degree function, we can now use quadratic formula. All right? Let me see what I have in some calculators, though. Let's save some time here. I will vote today, if you can count on that. Let's see.
Yeah, let's go. Man, I love them blue and black person.
Do ya? Guess what Parson has in calculators here? Let's do this. I'm not going to make you write it all the way out. Quadratic formula. We got down to 6x squared minus what, kids? Minus 12x minus 12. So what are you going to plug in for a, given what we have for that quadratic now? 6. What was the b value?
12, negative 12.
And what was the c value?
Negative 12.
Okay, here's my answers here. We get two answers. It says 1 plus or minus the square root of 3. Now keep this in mind because this is going to lead into our next core concept. We get 1 plus or minus the square root of 3. So when I go 1 plus the square root of 3, it's about 2.73. When I go 1 minus the square root of 3, we get about what? Negative 0.73, right? Can you remember those two values? Okay, 2.73 and negative 0.73. Let me show you something here quickly in your notes. Okay. First of all, we had to do synthetic division. Try to get your function broken down into what type of a function here, kids. What kind of a function is this? It's a squaring function. It's quadratic. If you get down to the part where you say, ooh, this is a quadratic, where do I want you to go to find the rest of your roots? Well, quadratic formula calculator. Okay. So here's the deal. In your notes right here, I think I'll have you write this. The solutions to this are 1/2. That was one of the solutions, right? Another one was, wasn't it negative 2/3, Cheyenne? Was it negative or positive? And then once we use that to get down to a quadratic, we said, well, quadratic formula might not give us rational roots, but it might give us irrational roots. Once I got that down to a quadratic, I plugged in the 6 for A, the negative 12 for B, and the negative 12 for C. Those values were about negative 0.73 and 2.73 for that. Okay. Now I'm going to show you something, and I hesitate to show you this because I don't want people just typing it in and saying, oh, those are the answers. Is this going to take a little bit of work? Absolutely. Okay. And come quiz or test time, I'm going to say, show me your work for this, all right? You can verify if the work you've done is correct. Anybody want to know how they think they can verify this? Type it in. Okay, so if I jumped into decimals per se here, somebody read that function to me again.
Which one?
The 6x to the, was it 6x to the 4th to start?
Oh, the first one?
Yeah.
6x to the 4th.
Okay, hang on, let me catch up here. So 6x to the 4th.
Minus 11x to the 3rd. Minus 16x to the 2nd. And then minus, or plus 2x.
Plus 2x.
Yeah, plus 4.
Plus 4. Okay, so guys, really when we say we're looking for roots, we're looking for zeros, here's what we're really doing. All right? There's actually two values right down here. All right? There's going to be one there and one here. Does that negative 0.73 look familiar?
Yeah.
How about this negative 0.66? What is that?
2/3.
It's the negative 2/3. What else do we have for our root?
We'll have
What was the last root?
2.73.
Is there a way to check your work? You're looking for the zeros, or where it crosses what, guys? Everywhere it crosses the x-axis. Okay? Everywhere it crosses the x-axis. So that's a good way to do that. Okay? Rational root there. You need to identify p. You need to identify q. You need to figure out what p divided by q possibilities are. You need to check them all synthetically, which that's the hard part, checking them all. So when you get your list made, come up and talk to me. I'll help you by telling you which one to start. I don't want you wasting a lot of time, but this is a great way to check. Now I want to back up on that calculator where we had calculator sloop. That 2.732 and that negative 0.732 came from 1 plus or minus the square root of what? I think it was 3, wasn't it? All right, let's talk about that because that's a pretty big idea here. This last example I want to talk about. This is pretty easy, but there's some pretty important stuff in here. This is called not the rational root theorem, but the irrational conjugates theorem. If I had x plus 7, what's x plus 7's conjugate? What's the conjugate of x plus 7? X minus 7. Okay? X minus 7. So here's what this says up here. It says let f be a polynomial function with rational coefficients, and let a and b be rational numbers such that this should say square root of b is irrational. It says if a plus the square root of b is a 0 of f, then a minus the square root of b is also another 0. So for instance, if I tell you, hey, kids, one of the roots for a function is 1 plus the square root of 7. What's another root then? Oh, yeah, 1 minus the square root of 7 would be another one. Or if I say, hey, 12 plus the square root of 5 is a root, what's another root? If I say 12 plus the square root of 5 is one of the roots for your function, then that means the conjugate also has to be a function. So what's another function? Exactly. 12 minus the square root of 7. Example 5, pretty important. We're going to use this. Here's how this works. It says write a polynomial function f of least degree that has rational coefficients. A leading coefficient of what, kids? 1. And the zeros are what? 2 and 3 plus what? Okay, here's the deal. I'm going to write down my roots first here, kids. My roots are going to be 2, 3 plus the square root of 7. Those are my only roots, right? Gabriel, you're shaking your head. No, those aren't my only roots. Are there others?
Yeah.
What's another one?
3 minus the square root of 7.
If you have something plus a square root of something like this as one root, then the other root is also going to be the conjugate of that. That's what this says up here, irrational conjugates theorem. If you end up with something goofy like this as a root, 3 plus the square root of something, then another root has to be 3 minus the square root of 7. Now I want to look and see how they write this. I want to know if they expand this for your assignment or if they just write it in factored form. So let me check and see. Oh boy, oh boy, oh boy, oh boy.
It's movie day again, Parcel.
Can you believe it? I can't. Now what are we watching over there? Oh.
What are they watching? It's like a 5-hour movie.
Okay, here's how this works, kids. To write our function, they want us to expand it. So what we need to do is write this out in factored form first. So here's how you write this. Okay, this will be pretty important to know. Your function, f of x, is going to become the following. You set this up as x minus 2 first. Okay? You type that up as x minus 2 first. That's going to be one root right there. Okay? Because what would go in here to make this equal to 0, kids? 2 would, right? All agree with that? Then your next one, you would multiply by x minus, minus in parentheses 3 plus root 7. So you're always setting these up. If you know what your roots are, you're setting up as x minus your root. X minus your root. And then the last one would be x minus Okay, now I'm going to simplify this a little bit further because they want us to expand this. guys with me so far? Okay. Do you guys agree that the minus sign right here for this middle term is going to make this 3 a negative 3? And do you agree that this minus sign will make the plus root 7 a negative root 7? Okay, so I'm going to write this as follows. I'm going to write this as x minus 2 times x minus 3 minus root 7 times x minus 3. What's this minus sign going to do to this minus sign? Make it positive. Okay. So let me make some room here. All right, here we go. We're going to start expanding this puppy. This is not going to be fun. Anytime you have to expand this right here, start with the ones that have the root in here. So I'm going to take everything in here times everything in here. You ready for this? I'm going to take the x times the x first, kids. What is x times x going to be? Okay, and maybe I should back up on this. I'm going to leave the x minus 2 alone for now. We'll multiply that in last. So I'm going to leave this as x minus 2 times the following. Here we go. The x times the x first would be x to the second. How about this x right here times the negative 3?
Negative 3x.
Minus 3x. Okay, and then the x times the root 7. Won't that be plus x times root 7 there, kids? You agree with that? So I've taken this x right here times everything over here so far to get that part. Now I'm going to multiply everything that I underlined over here by what middle term here? Negative 3. Okay, here we go. What's negative 3 times the x first? What's the negative 3 times negative 3? Well, that's plus 9. And then negative 3 times positive root 7 would be minus 3 root 7. Whew! Okay, so I've taken negative 3 times everything over there. Now I've got to take everything on the right times what? Negative root 7. So this is going to be negative root 7 times x, which would be minus x times root 7. Whoops. And then what's a negative times a negative going to be for those two terms? So plus 3 root 7. And then a negative root 7 and a positive root 7. Let's see, what's a negative times a positive? Negative. Square root of 7 times the square root of 7 is really the square root of 49, but that's really, what is the square root of 49? So this is going to be minus 7 on the end. Wow, we made it in there, okay? Let's look at this long set of parentheses and see if anything cancels out. Guys, I see an x root 7, positive x root 7 and negative x root 7 right here and here. So what are these going to do, kids? They're gone. I also see a positive 3 root 7 and a negative 3 root 7. What are they going to do? They're going to cancel. What's happening with all of the roots in this right here, kids? All the roots just kind of went away, didn't they? So this becomes the following. It becomes x minus 2. All right, help me, kids. Does this x squared in here combine with anything? No. All right, help me. We've got the x squared taken. How about this minus 3x? Does that combine with anything? Another one. So won't this be minus 6x? Okay, so we've taken care of this and this. And then it looks like, could I combine the 9 and the minus 7, kids? Which would be plus 2, wouldn't it? Hey, does that look a little more manageable now? To multiply out? Okay, help me multiply everything. Let's take this x times everything over here on the right. So, what's the x times x to the second now? Yep. Minus. And then x times the plus 2 would be plus 2x. And we'll multiply everything else by negative 2. So we're going to go minus 2x squared. Negative 2 times negative 6 will be plus 12x. And then negative 2 times positive 2 will be a minus 4. Okay, I'm going to squeeze this last answer in at the very bottom here. So let's combine terms. This is going to become x to the third. How about the 6x squared terms? What's that become, kids? Or the x squared terms, I should say.
8x.
Minus 8x to the...
Second power.
How about your x terms?
14x.
How about your constant term? Whoa. Guys, what were the roots to this function? What were the roots to this function? Originally, I told you 2 and 3 plus what? Square root of 7. But by irrational conjugates theorem, if 3 plus root 7 is a root, then what else must be a root?
3 minus.
3 minus root 7. So to write our function, we write this down as x minus 2, x minus the first root, x minus the second root, x minus the third root here. And then you have to multiply that whole mess out. Okay? Who has a calculator handy for me? Take 3 plus the square root of 7 for me. Okay. And then somebody do 3 minus the square root of 7.
7.3.
0.35?
I like 0.35. And the other root was 2. So if I put our function in, what values should I see on my Desmos? What should I see on Desmos, kids, for values? Well, 2, 5.64, 0.35. What did we come up with for a function? Somebody read what we came up with. X to the what? What did we get for an answer there? Minus 8x squared, you said, kiddo?
Yes.
Okay, what was after that?
Plus 4 till minus 4.
Okay, let's check our roots. 5.64, does that match what we thought we might get? 2, is that one of them?
Yeah.
Hopefully we get point what on this last one?
5.
We have to be what?
Right.
We have to be right. Okay? Guys, a lot of stuff going on here today. A lot of stuff going on. I'm going to hand out a quick quiz. I held back on getting you your assignment sent out. I wanted to make sure I got through that, so I'm going to send out the online here. Guys, in order to solve these equations, what do you have to make sure your equations equal first? 0. So my question is, what if I had something like this? What if I had something like x squared equals 2x like this? What would I have to do to both sides before I can proceed on that? Does that equal 0 up there? So what I would have to do is subtract a 2x from both sides. So to solve something like this, this would be x squared minus 2x equals 0, and then you're on your way. Okay? Guys, do your best with this. I don't know if you'll get done or not. As you're doing a quick quiz, I'm going to try to get your assignment out to you. Guys, remember quiz deadline, quiz bake-up deadline, what's the date? 13th, all right, November 13th.
Hey, Parson.
Yeah.
I'm gonna come in during cleaning time to finish my test.
That's fine, that'd be great, I appreciate it. Anybody else need to come in during lunchtime to finish up?
I might.
Keegan, you said you were done, right, buddy? Just wanna hang out in the cool room, though. Yeah. There you go, buddy. All right, hey, you guys have any questions then? I encourage you guys, help each other out, bounce ideas off of each other. You get stuck together, then come talk to me. But try and work your way through this, and we'll see where we get with that, okay?